Thank you for the invitation here, Sanjay and Kirsten. It's delighted to be here to talk about a topic that's near and dear to my heart and my mind, conversational AI and Alexa. Let me just make sure. So all of us dream, right? The American poet Langston Hughes said in his poem, Dreams, he said, hold on, hold fast to your dreams. If dreams die, then life is like a broken winged bird that does not fly. And many of our dreams in the field of AI are inspired by science fiction. When I say science fiction, for anybody who grew up when I did, Star Trek is sort of an immediate recollection. But we were promised many things in science fiction. We were promised jetpacks. We were promised spaceships. We were promised holograms, autonomous cars. We were promised the future. Right? And some of these dreams are coming to fruition super fast. That is a hologram of Tupac Shakur. That's not Tupac, and it's a super high quality. Spaceship, of course, I don't know if you recognize the guy in that picture, but and this, of course, is William Shatner. So science fiction, the science fact, Alexa is present everywhere. When I was thinking about what to title this presentation, I thought I would be modest. I would call it Alexa AI Everywhere. Right? But we use everywhere in a somewhat commonplace way. It's in the sense that it's everywhere. It's every day. It's every activity. We want it to be your assistant, your companion, advise you on things. Alexa is also capturing and shaping public imagination today. Right? When Saturday Night Live does a skit on you, you've sort of arrived. Right? And what do I mean when I say Alexa is everywhere? We're Echo devices that are sort of a primary conduit for Alexa, are available in 80+ countries. Millions of customers use it every day. And localized experiences, super important to us, is delivering localized experiences that are culturally appropriate. Amazon, as you know, is all about delighting the customer. You don't delight the customer by not looking like one of them, sounding like one of them. And so localized experiences are super important to us. So this is where we are. Conversational AI is center stage. It's a reality that has come to fruition. It's where Amazon invented a new niche market in conversational AI with the Echo family of devices. But where did it all start? How did we get here? Started off in a very simple way with character mode interfaces, with graphical user interfaces following quickly. And then the web, which introduced a sense of abstraction to all of this interaction, because now your computer is a window to the rest of the world. It's not just in itself a world. The mobile platform allowed you to carry this window with you. But the advent of voice user interfaces, what we now colloquially call conversational AI, has sort of made ambient computing possible. You no longer need tactile touch. You're going on with your day as usual. You're just talking to your environment, and whoa, the environment talks back to you now. It responds to you. That's a major milestone for us. And so what does Alexa, just like a quick look at the simplified brain, a simplified look at the Alexa brain. So you might start with an utterance that says, Alexa, play Message in a Bottle by Sting. Right? The utterance is captured. It goes in through a speech recognizer. The recognition result comes out. Maybe it's a single result, or it's a lattice of alternate hypotheses. They're then processed by the natural language understanding engine. You identify the intent along with the arguments around the intent. So if you're saying play a song by artist X, maybe it's the play music intent, and the artist X or the song Y is the argument or the arguments. That's then, there's an ER layer or an entity resolution layer that then brings this all together and says, within the package of something we call a skill, delivers this content over to the customer by translating these intents and associated arguments into actions that can be taken by the device, and then you play out the audio content and you deliver satisfaction. Right? So how do we make this happen? This whole thing about Alexa processing all these utterances and producing it out. From a developer perspective, there are two broad frameworks that we offer. One is at the very front end is the Alexa Skills Kit. The Alexa Skills Kit is how you deliver content to your customer and you delight your customer. The second is the Alexa Voice Services. This is how you deploy Alexa itself on your favorite device. The Echo family of devices is one set of devices on which Alexa is deployed, but you can have other devices manufactured by other people that also carry the Echo family, the Alexa Voice Service, and give you access to all Alexa services. So today, Alexa developers, it's a big development community. In fact, this 325,000 keeps growing. We've run out of time to update our slides fast enough with the growth in our developer community sometimes. Nearly 50,000 skills, many different device types, literally thousands and thousands of personal skills. Add to it blueprints, routines. So you can say to Alexa, you can set it up so that you come home and you say to Alexa, good evening or good afternoon. And if you have a smart home, Alexa can be coded to take a bunch of actions like raise the curtains, start your tea kettle, brew tea for you, things like that. Or you're going to sleep, you say, Alexa, good night, make sure all the lights in the home are turned off, the security system is on, etc. And you can see a wide variety of partners have been using this. But consistent with this growth in the number of skills, the number of features that we deliver to the customers and enable a richer end user experience is a drop in the error rates. Because as you increase the surface area, the VUI surface area, the burden of reducing the error rate becomes greater and greater. Some of these skills are exercised less than others. Some of them are more complex. So we've put in a huge amount of effort in making sure that concomitant with the rise in the number of skills is a reduction in the error rate so that the customer experience continues to improve. It's not just richer, but it continues to improve in fundamental ways. Growth for Alexa has been driven through these kinds of rapid innovation. We're very grateful to all the brands and developers that have adopted Alexa and made it sort of a platform for delivering content to a lot of our users. So this is where we are, right? This is sort of where it started. This is where we are now. Alexa is everywhere. So where next? When we started with Alexa, Amazon made a fundamental promise to its customers that Alexa would become smarter every day. As you interact with Alexa, she will improve. She will become more capable every day. And we have held true to that promise. One example is that graph that I just showed you, where it sort of summarizes overall performance. The error rates have gone down. But we've improved every foundational component of Alexa: ASR, NLU, entity resolution, linking, text-to-speech. But now we are at an inflection point in sort of this capability growth. In addition to improving these foundational components, we need to improve Alexa in different functional areas. We're trying to make Alexa more competent, like she has more proficiency, more competency. A lot of this also has to do with context awareness. If you talk to a particular device, you might want it to behave in a certain way. You talk to it at a certain time of day. You talk to it with certain personal preferences. Each of these, you want it to inform Alexa's response to you. Knowledgeable. We want Alexa to be able to answer more and more questions. I'm sure you all saw this video where our fearless leader said, ask Alexa what is 50 factorial. And actually, people did ask it all kinds of different factorial questions, and thankfully it answers correctly, right? We want to make it more natural. The whole premise here is natural interaction, is that that the cognitive burden is shifting from you to the device. It's not like I've given you a new device, and here are like 5 new buttons. You saw me, right? I was looking to see, and then I said, oh, this large green button must be the one that advances it, right? That's a little bit of a cognitive burden for me, right? But it's fine. It's one I can overcome on the fly, right? But we want it to be natural. I just want to say, next slide. And I would like the next slide to go on. Why do I need to learn how to operate this device, right? Similarly, self-learning. In addition to users teaching Alexa, we would like Alexa to just observe usage and become better. Identify errors, figure out how to transcend those errors, and become better. So I can't obviously go through the whole details here, but I'll give you a quick look at some of the key things that we've been doing. So one, this whole notion of competency is built upon a pervasive, deep learning is just pervasive throughout our system. Sanjay was talking about how the revolution has been enabled through new architectures, new algorithms, et cetera. So there's a confluence that's happened, right? We live in a very instrumented world. There is access to massive amounts of data. And then for the first time, we're actually able to pump that massive amount of data into our algorithms and learning techniques and produce models and representations that consume all that massive amount of data and produce more complex capabilities. So we're living at this sort of fortunate time where all of these things are coming together. And so deep learning is sort of become the catchphrase that captures all of this together. But deep learning is pervasive throughout the system. We started off, we have lots of data. The Alexa devices are out there in the field. You have lots of compute with AWS. We have storage in AWS, right? Thanks to all the devices manufactured by companies around the world. So we were able to bring all these together and deliver this delightful experience, magical experience called Alexa. But we've not stopped there. As the scale of Alexa grows, we can't keep relying on more and more data, especially if it means more and more annotated data. Annotated data is super expensive. If you want people to annotate data, it takes time and it's costly. So the question was, can we reduce the amount of data that we need to make Alexa perform just as well or even better? So a recent advance in the last 6 months, active learning has led to a 40x reduction in the amount of training data required to achieve the same performance. Yeah, it's not 40%, it's 40x reduction in training data required. The second important advance has been transfer learning. I'll talk about it in the slide. You might have a data-rich domain like weather or restaurant. You've trained your models, you've invested a lot of effort in it, and those features are working just fine. And now along comes somebody who wants to build a skill and says, it's called recipes. So we would like to be able to transfer as much knowledge, as learning as we can from these weather and restaurant models over to the recipe models. And we're able to do that now. The key advantage of these advances is that these improvements happen in the back end. So the skills developers have to do nothing, and they will see a 15, 20% improvement in performance automatically with the same skill, because we've just implemented these transfer learning skills. So these are a couple of examples. Moving on to context. More and more in intelligent interactions with devices, with applications, it's about context. Most of the intelligence or the appropriateness in the response comes from a good consideration of context. So I'll give you a simple example. What's Adele's latest soundtrack, right? And then after that, you say, play it. As humans, we do this automatically. And maybe even in the case of a machine, if I say, play it, and it is explicit, it feels like a less challenging. I'll follow up with a different example later where a deeper challenge is also being addressed. But here, we again use deep neural networks. It's called an encoder-decoder architecture. I'm sure there are many people here in the audience who work with these every day. You also don't have to say, Alexa, every time you turn on follow-up mode, and it knows that you're continuing the conversation. Second is multimodal context. Many of our devices now have screens. The screens enrich your experience, especially for shopping. So you want to buy a blue shirt. She will show you a bunch of blue shirts on screen. You might go and pick one by clicking on it. You might also just want to say the second one, place an order, and she'll do it. Third is device context. So if I say play Hunger Games or play Lost City of Z, and I'm sitting next to my Echo device, Echo speaker, maybe I wanted to read out the book, the Kindle or Audible book. But if I say it sitting next to a screened device, then I wanted to play a movie, right? So there are things like this that combine device context and contextual signals. There are just dozens and dozens of them. So I'm just giving you a few examples. Personal context, you might want to say play music. You want to say play my music. But if I have speaker ID, when I say play music, and it knows it's me, right? Maybe I don't have to say play my music. right? So we're using Speaker ID both for this and to authenticate folks for doing shopping and things like that, so that the whole goal is to reduce friction at every point. It's to reduce the experience that you're calling a call center and says, please tell us your phone number. And then somebody else picks it up, asks you the same question. We want to reduce friction for the customer. Right? A peek into what's coming in the next few months. One is this Alexa Guard feature. So as you're leaving your home, you say Alexa Guard. And it starts listening to acoustic events, maybe a smoke alarm, maybe a glass breaking, and it will send you an alert to your app on your phone, and then you can take follow-up action as needed. Of course, I mean, despite active learning, we still had to break quite a few window glasses to get the data for this. But there are, thankfully, cultures where breaking glass is lucky, right? So I come from one of them, right? Anyway. Whisper mode. So Alexa now sort of tracks you. Most of you, when you're talking to someone and you're having a long conversation, you will notice that you start adapting your speech patterns in a certain way, whether it's the prosody of your speech or certain accentuations, to match. Nowadays, for the last several years, it's been like people start using it, and empathic growth in those speech patterns. Alexa is now starting to learn how to adapt to you, your speaking style, not just your content. So whisper mode is one of them. So if you whisper to Alexa, she will whisper back. The important thing is, this is a showcase capability that showcases this ability to understand your style of speaking and mimic it. It's not a heavily feature engineered thing. This is actually learning the style and mimicking it. This is just an example that is very evocative and is a nice demo. Natural interaction. So when you started off with Alexa, there was a certain set of things you could do. And maybe you can learn how to talk to Alexa in a way that she understands you, or any conversational AI. But as Alexa starts doing more things, the burden of trying to learn how to say all of these more things to Alexa in a way that she understands becomes much harder. So naturalness becomes a more and more important aspect of conversational AI as the user surface area increases. So for example, you say, Alexa, I don't know how many of you use it. I use this feature all the time. Remember that I left the drill package in the garage, or remember that I left my keys on the dining table or somewhere else. And then you ask her, where are the keys? Or where's the drill? You don't want users to have to remember exactly how they said it when they enrolled the memory into the device. So you have to do semantic search. All of these are examples that are somewhat simple, so they're relatable. But these kind of semantic queries apply to more complex situations as well. A second example is when we started off, you had to say, Alexa, ask Uber to get me a car. And it's great if you have 4 skills, 5 skills, 10 skills, 20 skills, and at some point your ability to remember all the skills breaks down, right? And so what you would rather do is say, Alexa, get me a car. And in this case, we blend in all kinds of deep learning along with contextual signals and user preferences to come back and say, here's the car for you. Another thing that's coming up, multi-step request, or it's already been released in one shot. You want to add multiple things to your shopping list, you can do it. The interesting thing here, I guess, is the peanut butter thing. If you have this, it's 2 words, you still have to make sure it's added on as peanut, not peanuts and butter, right? Slightly more complex is multiple intents. You might want to say, play Hootie and the Blowfish and turn on the bedroom lights at the same time. And Alexa will satisfy that request as well. Remember when I said it's great when the context you're trying to carry over is explicit, like play it, and you know that it is a reference to something, so you try to go disambiguate it. Sometimes the reference is not so explicit. Is it going to rain in Portland today? And Alexa will give you the weather and say yes or no. And then you say, and tomorrow. And now there is no, it's all latent. What is the reference to and tomorrow? The next part to it is, what if I then say, and what about Boston? Right? So you need all of these things to come together for satisfying. So there we use probabilistic learning, machine learning to do it. The last thing in terms of machine learning capabilities that I'll talk about is self-learning. And I'll just give you one example. You talk to Alexa, and your way of asking for a music station is play Sirius XM Chill, right? And Alexa, the way the skill was configured or designed, or the data that was used to train, does not know what XM Chill is, or this channel is. So then the user barges in and says, no, 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 I mean play channel 53 on Sirius XM. So the question is, can you use these kinds of information from the user interactions that you have to automatically learn equivalences between different queries? And then the next time a user asks, some other user asks you to play Sirius XM Chill, you can automatically satisfy it without a single user in the loop annotating this error, fixing the problems, et cetera. So we're already working on these kinds of capabilities right now. So looking ahead, many in the community, in the AI community, talk about the AI stack. So the AI stack is sort of moving up from simple signal processing and data capture and transducing that signal, like speech signal into speech recognition, et cetera, moving up to making some kind of intelligent decisions with that data. Which song did you want? What action do you want me to take? Then moving further up into reasoning, helping me with much more complex tasks. And then there is autonomy. Now, off the top of the stack is this thing called automated general intelligence, which is sort of the holy grail of this whole field, right? But we would like to get all the way up to autonomy in the foreseeable future, right? So the example I'll give you is, you might actually want Alexa to help you what to make for dinner. The whole idea here is moving from simple query response type engagements to actually transferring significant cognitive burden from the user to the device. So what should I make for dinner might start with some suggestions. She learns your preferences. Maybe she can connect you with the right kind of things. Maybe it grows into your shopping list, your grocery list, and then the grocery order is placed, it comes in. Maybe it's about travel plans. What's the weather like in Tahoe this weekend? Each one of these exemplifies a super hard set of AI challenges that need to be solved. So in summary, I will just say that if this is like a bicycle race, we are very much at the start of the race, at the start of the Tour de France. But it certainly looks like it's going to be a super exciting ride and a super exciting bike ride. You know, it's a long bike ride. AGI is still a very long ways off into the future, but we're working towards moving up the AI stack. Thank you.